So in this video for chapter 7, I will mainly talk about the profit maximization. This is a very important concept and it's a very basic concept. Again, this is something we will use a lot later on. So what is profit? Profit is the revenue minus the cost. The revenue is usually the price times the quantity. Assuming basically for every unit you're selling for the same price. This can change in future chapters, but for now, this is a good assumption. And then the cost should be the opportunity cost. It is not the accounting cost. It is not the explicit cost. It's the so-called implicit cost that including the opportunity cost of all the inputs used in the production. Then the profit is the difference. Right? If the profit is negative, then the firm is losing money. And as we all know, the firm tries to maximize the profit, make it positive, and make it as big as possible. So here is a very generic, very general picture for the profit maximization problem. What we have is a total revenue curve, and notice this revenue curve is also concave. What it says is basically as you sell more and more, eventually that may drive down the price. When the price is lower, the additional unit may cause the price drop too much that your total revenue actually decline. Okay. The cost is increasing when you produce more and more quantity. At least for the first one, we can understand this as the diminishing return of labor, right? Diminishing marginal return of labor. And the profit is the difference between the two. Okay, this yellow line here, plot the difference between the purple line, the revenue, and this light blue line, the cost. And from what we can see here, right, the distance start kind of small, at least from Q0, is start from small and become bigger and bigger, and then decrease again. So the yellow line, at least from Q0, will increase and keep increasing until Q star, the highest point, and then start to decrease. So the idea is that we want to produce at a Q star that maximize the profit. And assume that right, this yellow line is smooth. What do we know? We know that before Q star, right, this profit line is upward sloping. So the so-called marginal profit, the profit you make for each additional unit you are selling, right, is positive, right? One more unit sold, bring in more profit until right, the marginal profit becomes zero, right? Here at the top, the marginal profit is zero. It's basically the marginal profit become lower and lower. It's still positive, right? Each unit you make money, but the money you make for each additional unit you're selling is less until it hits zero. Then you want to stop, because if you go further, the so-called marginal profit become negative, and that hurt your total profit. When you have negative marginal profit, you can see for this portion, right, the quantity beyond Q star, we have a downward slope. Okay, a downward slope. Now let's look at what makes the marginal profit in this portion between Q0 and Q star. It's positive, but declining. What happened? Right? what's going on is, well, the revenue, right, when you sell more and more, is increasing. You have more and more revenue, but still it's going towards flatter, right? When it's flatter, the so-called marginal revenue decline, right? For each additional unit, you bring in less marginal revenue. How about the cost here? The marginal cost actually increase, right? We have been talking about increasing marginal cost as always. So what's going on? You have lower and lower marginal revenue, but a higher and a higher marginal cost. Below Q star, what can happen is also above Q0, right? Between Q0 and Q star, what do we have? We have positive marginal revenue, which is declining, positive marginal cost, which is increasing. So as you're getting closer and closer to Q star, the marginal revenue is smaller and smaller. The marginal cost is higher and higher, which make the marginal profit smaller and smaller. Still positive, but smaller and smaller. Until at Q star, the marginal revenue equals the marginal cost, right? I have this two tangent at point A, right, for the marginal for the revenue curve, and at point B for the cost curve. These two tangents, their slopes is the marginal revenue at point A and marginal cost at point B. And I show that at Q star, right, these two tangents has the same slope. They are parallel. So you have marginal revenue equal to marginal cost. That makes the marginal profit 0. And we have said, right, when you have 0 marginal profit, basically you're selling this 1 unit, you bring in as much as revenue as how much it costs you to produce. You're not really making money here, right? And that means if you go further, what can happen? The marginal revenue fall below marginal cost, give you negative marginal profit, right? You already earned $100 profit. The next one is negative 50 cents. It make your total profit going from $100 to $99.50. That make the profit curve decline. So you do not produce beyond Q star. Okay, you stop at Q star to maximize the profit. And above Q star, what you have is marginal revenue is lower than marginal cost, so the marginal profit is negative. Below Q star, above Q0, you have marginal revenue higher than marginal cost. Even though they are getting closer and closer towards Q star, but you're making positive profit, your total profit, this yellow line, the total profit is rising. And after Q star, the total profit is declining. So you stop producing at Q star to maximize your profit. That is why we have the 3 rules, right? And let's look at the textbook picture here, right? At Q star, where it maximizes the total profit, you produce at that quantity. And the second rule says what? Set output where marginal profit equals 0, right? I have explained that. This is the change in the profit. The marginal profit is basically the change in the profit for every unit you produce additionally, right? That is 0. Make you know that at that quantity level, it's the highest profit you can make. And then when you have marginal profit is 0, basically you have marginal revenue equal to marginal cost. And we will talk about the calculus later on. What it says is basically we want to have a marginal profit equal to 0, and because profit equals revenue minus cost, right? You differentiate profit against the quantity equals the revenue differentiated against quantity and differentiated the cost against the quantity. That equals 0. The first term here, right, differentiate the revenue against the quantity is the marginal revenue. The second term, differentiate cost against the quantity is the marginal cost. So you have marginal revenue equal to marginal cost. That's what this profit maximization gives us. And again, let me emphasize, below Q0, what we have is marginal revenue higher than marginal cost, even though as you increase the quantity, the difference is smaller and smaller. But at least before Q0, you can have a portion that you keep adding profit, right? Even the profit, additional profit, the marginal profit is declining, but you still add positive marginal profit to your total profit, so your total profit is rising. Now, beyond Q star, beyond where the marginal profit is 0, or say where marginal revenue equal to marginal cost, we have declining total profit because the marginal profit is negative, right? You keep losing money on top of what you have earned, so the marginal profit is negative, so your total profit is declining. And what it says about the marginal revenue and the marginal cost, it says the marginal revenue is less than the marginal cost. Make your marginal profit negative. That's why we have this declining total profit here, right, above Q star. So now let's review a little bit of the calculus that we are going to use in this class. The most basic first order derivative we need to consider is the first order derivative of a power function. So let's consider a power function of x to the 8th power. And if you have learned calculus before, the first order derivative with respect to x is a, the power, right, times x to the a minus 1th power, right? So basically you carry the power down in front of x as a coefficient, and then the power on x dropped by 1, right? So let's look at some examples. And first I differentiate 3 times q squared against the q, okay? And what is going on is 3 is still here. It's part of the coefficient on q. And it's really the q squared that is being differentiated with respect to q. So the power come down as a coefficient standing before q is basically 3 times 2 times q to some power. And the new power, right, after first order differentiation, you got the original power 2 minus 1. So q to the 1th power is just q itself. So now what do we have? We have 3 times 2 times q, right? That's 6 times q. So what do you do when you see a constant times q squared and you want to differentiate? You will just use the constant times the power and put q behind it, right? So 3 times 2 times q. So that is something to memorize, right? If you haven't learned calculus before, just use it as a formula. It is a formula anyway. What it says is basically for very small change in q, right? How much this 3 times q squared will change? The change will be 6 times q. That's what it means. All right. Now look at another example. It's just a constant times q itself. No power there, or say 1th power, the first power. So differentiate 12 times q with respect to Q. We have 12, we carry it over, right? Just like a 3 here, carry it over to 3 times 2 times Q. And here is 12 times Q, so you carry the 12. And the Q is now what? To the 1 minus 1. 1 minus 1th power. So the power drop 1 is Q to the first power, drop 1 to the 0th power. Anything to the 0th power is 1. So it's 12 times 1 is 12. So when you see a constant times Q, and you want to know the first order derivative, it's just you take out the Q, right? Take out the Q, you got the constant. Easy enough. Constant times Q squared, 2 times the constant, and put Q still there because it's square. You still got 1 power left. What if I differentiate a constant against Q? Well, there's no Q in the constant, so no matter how much Q change, the constant won't change. Then the first order derivative must be 0. It is 0 because 100 is not a function of Q, right? No matter what Q does, 100 does not do anything. It doesn't change with respect to Q, so the first order derivative of 100 with respect to Q is 0. Now 12 times Q, right? If I change Q by 1 unit, 12 times Q change by 12. So that's why the first order derivative is 12. Okay, now with these formulas, we can proceed to consider our profit maximization calculations. Look at our revenue function. It is 120 times Q minus 2 times Q squared. Okay, it's a constant times Q and a constant times Q squared. So this is the revenue function. And the cost function is 100 plus Q squared. What is our marginal revenue function? We differentiate the total revenue function with respect to the quantity, right? Then what do we have? We have 120, right? The coefficient here, let's pull it down, minus 2 times the second power, 2 times 2, that's 4, times Q itself. It's the square dropped by 1 power, right? 2 minus 1 is 1. So the marginal revenue function is 120, right? 120 minus 4 times Q. Okay. How about the marginal cost? We differentiate the cost function with respect to Q. The 100 doesn't change with the quantity, so its first order derivative is 0 with respect to Q. And Q squared, we just take the power into the front, right? And drop by 1 power to Q. So it's the marginal cost is 2Q. Now we have a marginal revenue function equals 120 minus 4Q, and the marginal cost function equals 2Q. Right? Now we are ready to maximize. We want to have the maximized profit. We want to know what is the Q star, right? We produce as a Q star, we can maximize our profit. So equal the marginal revenue equal to the marginal cost, right? Equal the marginal revenue to the marginal cost. We have 120 minus 4Q equal to 2Q. And what I'm going to do is basically, well, I move the 2Q from the right-hand side to the left-hand side. If I do that move, I flip the sign, right? So it's positive 2Q on the right-hand side, and then on the left-hand side will be negative 2Q. And for negative 4Q and minus 2Q, you got negative 6Q. Well, if you do not get the flip sign business, right, when you move one item from one side of the equation to the other side, you flip the sign. That's the rule. Okay? What you can understand is, well, what if I deduct 2Q on both sides of this equation, right? So I minus 2Q on the left hand side. I got minus 6Q because I have minus 4Q before. And 2Q minus another 2Q, which is 0. Same result. Okay, so this is the technique to solve this equation. You can understand things by saying, all right, I deducted the same thing on both sides. And if you follow the rule, it's just when you move things around the equal sign, right, you need to flip the positive or minus sign. And then now it's one equation for one unknown. We have 6Q equal to 120. Use your calculator, you can calculate the Q star, which give us the maximized profit. It's 20. So you produce 20 units in given this total revenue function and the total cost function, you will be able to maximize your profit. So let's look at the total profit function, right? It's just the revenue minus the cost. And what it is, it's revenue 120Q minus 2Q squared minus 100 minus Q squared. So I line them up with Q's power increasing. The first term is actually the minus 100, has no Q in it. And then plus 120 times Q. And I still have minus 2Q squared. And because it's the cost, right, minus sign here, so minus Q squared. So we have minus 3Q squared. Again, the first order derivative of the profit with respect to Q is what? The minus 100 is gone, right? You have 120 left. 120 left here. 2 times 3 is minus 6, right? The minus sign carried over. 2 times 3. Q dropped by 1 power from Q squared to Q itself. So the same equation, okay? 120 minus 6Q equal to 0. That's the first so-called first order condition. You want to set the first order derivative to 0 to get either a maximum or minimum because, well, we have this concave shape, right? We know it's a maximum. Again, it gives you the same result. Same equation, same solution. Q star is 20. Once you produce at 20 units, you maximize the profit.